Hello again, stats class. We're going to look at how to do confidence intervals for proportions with Desmos in this video. So early on, you're seeing just vocabulary terminology. What am I being asked to find here? So it says find the point estimate for the population proportion, which is the sample proportion. So P, without the little hat symbol on it, is the population proportion, which is what we're actually trying to estimate. P hat is the sample proportion, which we can get from the information that we have. So again, I would have to ask in this country A, whatever this country is, let's just say it's the United States, just for simplicity. I would have to ask all 350-ish million people in the United States. Now, this is adults, so maybe 180 million, or let's say like 200 million. I'd have to have 200 million people surveyed if I did a population proportion. And that's just not possible. So I sample, I get P hat, and I use that as my best guess for P. That's a point estimate. So what am I being asked to do here? I'm being asked to just take the information I'm given from the survey, 271 out of the 415. So 271 out of 415, I'm sorry, 1415. And that's my estimation for P hat. So it says round this to 3 decimal places, so that's going to be 0.192. So 0.192 is my point estimate. All right, and then the next part says, okay, what is the estimate for Q? Well, just like with the binomial distribution, Q is 1 minus P. So if this is P, just put a 1 minus in front of it, and that's Q. All right, so to 3 places, 0.80. All right, you can also get Q hat from P hat just eyeballing this. So I need a number that the way it works is for how many decimal places you have, so typically 3. I need the first and second decimal places to add up to 9. So 8 and 1 add to 9, 9 and 0 add to 9. And then the last place value they need to add to 10. So 2 and 8. So you could easily get it that way as well, but you can also just put 1 minus what you got for part A there for the second part and get that as well. All right, let's look at margin of error calculation. So this is jumping down to question 5. So just like with the previous section, if you're given a confidence interval, the margin of error is the distance from the number in the middle up to the upper number. So you can get that. So this is double the margin of error. If I subtract these, I get double because I'm going from the upper end all the way down to the lower end, which is the margin of error is from the middle up or the middle down. So when I'm all the way, I have 2 margins of error. So if I just subtract these two, how they are now, I'm going to do division to get the division bar. And then I'm going to take the upper numbers of the 0.708, and I'm going to subtract the lower number, 0.680. That's the entire interval's width. The margin of error is half that. So divide that by 2. So there's my margin of error, 0.014. All right, then P hat is the number in the middle. So if you take the lower end, the upper end, and average them, you'll get P hat. So I'm just going to take this minus in the middle and change it to a plus. And that becomes the number in the middle once you average the two. So the 0.694 is the number in the middle. You can also get the P hat from subtracting this upper number, 0.708, minus the margin of error that you just got in the previous question. That will also give you that number that's in the middle. All right, now when I'm doing confidence intervals for proportions, and I'm just taking the information given to me and constructing the intervals completely, then I need to use the normal distribution menu. I'm going to move this over so my head's kind of out of the way. Actually, I need to get to the bottom of the screen so I can show you, just remind you, normal distributions is under functions. Go down to probability distributions. There's normal DIST. So you can get it from there. You can also just type normal DIST. That's fine. Normal distribution. So the center of this is P hat, which is your 712 divided by your 2010. So it's X divided by N is basically the notation that it talks about in our book. All right, and then the standard deviation, because we need the standard deviation for a normal distribution. The standard deviation for these is the square root. We're going to put a division bar under the square root. And then it's p hat, which is what this is. So I'm going to just grab that, copy it, times, let me get that comma out of there. Actually, I need to move this comma right there. Let me change it, sorry. All right, and then I'm going to do times parentheses 1 minus p hat. So I'm going to paste that again, get that comma out of there. All right, so that's p hat minus q hat, all divided by the sample size, which again, that 2010. So that's what I need to be able to get the right distribution. It's like in the last section, it was like this was the shift and this was the scale, right? It's just I have a different way to get the shift and the scale now. So instead of x bar, the sample mean, it's now p hat, the sample proportion. This is the same thing as it was for the scale. This is the standard deviation. It's just the standard deviation for population proportions is p hat times q hat divided by n, all underneath the square root sign. So we're doing the same thing. It's just we're applying it to a normal distribution, a z distribution, because it's proportions, and we are just adjusting to the fact that it's not sample means and sample standard deviations. It's sample proportions and the standard deviation of the sample proportions. So anyway, that's how we have to do it here. Now, another way you can do it, just to kind of neaten it up a little bit, I know this is technically p hat, but you could just call it p equals this number. So I'm going to just copy and paste it down there, but you would just do this on your own. And then instead of having all these ugly fractions within fractions, you could just call this p. You could call this p. You could call this p. And now it's much more condensed to not have those fractions within the fractions. But it's still going to give you the same thing. All right, I'm going to click on this just to zoom around it so we can see the distribution. And then we're making a confidence interval. So we're going to have to do the same things we did before with the last section. We're going to do inner. Because it's a confidence interval, we need a lower and an upper. And that's what inner does. And then 90% is our initial confidence interval. So we're going to go to bounds, make this be 90%, 0.9, or 90, either one. And then there's our two values that go here, are these two lower values. I'm going to I always click the upper one first, and then the lower one, just so it's lower to upper once I click them down there. And then we want these to 3 decimal places. So this will be 0.337, because it's a 66. And then the upper one is 0.372. So I'll copy that and just change it to a 2 at the end. All right, and so there is our confidence interval. It's 90%. Now the next part says, all right, now make it 95%. Well, all I have to do now is just change this from 90 to 95. Nothing else is changing. So I'm going to delete all that. I got to leave that because it's based on P. So again, I'm going to do upper, then lower, so it's stacked vertically. 3 places will be 0.333, and then 3 places on the upper number will be 0.375. All right, and then the last thing it wants me to do is interpret this when given with the given confidence. It can be said that the population proportion of adults, they say they have made a New Year's resolution, is between the endpoints of the given confidence interval. And that's how interpretation of confidence intervals work. All right, now it wants to know which one of these is wider. And the answer is that 95% is wider. To gain confidence, we have to go out from the center more. It's like a net. If you want to catch 90% of the fish, you need a net this big. If you want to catch 95% of the fish, you need a net that's bigger. So we need a wider confidence interval to increase the percentage likelihood that we have the population proportion captured in there. So it would always be the higher percent is the wider interval. All right, let's try this one more time. We got a 99% confidence interval. We're going to construct 334 is our sample size. This is many said they've started paying bills online, and we want a 99% confidence for not just the 3,334, but all of the adults. I would assume we're talking about the United States or the world, but just a larger population rather than these just 334, 3,300. So same thing as before. We need to know what P is, right? So that's going to be the 1437 on top of the 3354. So there's the value of P. All right, and we want a 99% confidence interval. So I'm going to change that to a 99. All right, and then since I've got it in that form, the only thing I have to always update is the sample size. So it's always this denominator. So I'm just going to replace that value. You got to remember to go back and update that if you use this P equals method. That's N on the bottom. So N will change from question to question. This will also change the confidence interval, so the confidence level. So change that, and then these should be your numbers. So there's my upper number, there's my lower number. To 3 decimal places, that's going to be 0.406, 0.450. All right, and I can check those. Okay. It will give you those to 3 decimal places here. So if it's only wanting 3, you can just grab them from here. Just know that when it doesn't give you a 3rd decimal place, that next number is a 0. All right, so that's confidence intervals for proportions. The key thing to remember here is your adjustment, your scaling, as it referred to on the T distribution menu with the standard deviation, is just a little different than it was before. It's P, Q, over N underneath the radical. So P hat, Q hat over the sample size underneath the square root. That's the big thing you got to make sure that you adjust along with your confidence level every time that you do a new problem.